Hi, my name is Wayne Davis,
And my name is Tristan Lee.
and we are both senior solutions architects for Amazon Web Services. We appreciate your time today, and we're going to talk about developing intelligent robots with AWS Robo. Some pretty cool technology, and you'll be very fascinated with the outcome. And when you think about the industry today, there's just lots of robotics out there that make up the robot world. So these different physical, autonomously driven things out there, as you see depicted in this slide, are extremely powerful for a very economical price. From self-driving cars to drones to walkers to underwater devices, there's just lots of opportunity for you and I both to be very creative with regard to how we do things in the industry. So moving forward, you'll see that there are certain specific technologies that we use in our fulfillment centers. And specifically, these robots here are autonomous devices as well. You also see in the bottom right corner our Amazon Prime Air services with robotics as well. All of these things, again, right, have very specific functions. Just as when you build your robot application, you will have specific functions as well. So, if you focus on the robotics life cycle, there are several different things that must take place. First, you've got to find out what specific framework you want to use. That framework is very verbose in the industry today. You also want to focus on how you specifically develop the application. And then, as you start to think about the test and simulation phase of the development cycle, you'll note that you'll iterate again and again on that to the point where you finally get to bullet point 4 here, which is how you deploy and then you actually manage the application. At this point, now you can start taking the new applications and you can update them and release them accordingly so that you can be successful. So it's nice because the robot operating system has been designed over the last few years to make sure that it's a many to many published environment. You have the Berkeley software distribution system that's developed over the course of time. It's got a large ecosystem of packages and tools that you can develop on your own or pull off the shelf. And the development community is extremely stringent and also plentiful if you want to go into that community. And then when we do our research and development, you'll see that applications are out there and it's something that we can all take advantage of. So, what about Robot Operating System 2? Well, it's been designed to be a lot more open. So, as you'll notice, it's an open source, it's Apache 2.0, and it's been developed specifically for commercial applications with regard to improving on the reliability, the security, and considerations in mind for consistency. One other thing you'll see that with regard to the open standards around data distribution, this is something where improvement has been made, and you'll see lots of support from Amazon and Intel and other providers out there as well. So, fast forwarding, we also know that thinking about robotics is hard from the physical aspect down to the software. You've got to figure out how you actually add the intelligence from a machine learning perspective. You want to make sure you capture your prototyping to make sure that you have lots of time spent around configuration, around the building, the simulation, and more importantly, the application management itself. So these things are very important, which is why we here at Amazon Web Services wanted to introduce you to a really cool tech called Amazon Web Services Robo Maker, AWS Robo Maker. Now, this service is built so that it will easily help developers to build, to develop, to test, to deploy all these robotics applications in a well configured manner and also be able to function as though they're in the cloud. When you think about the capabilities of RoboMaker, this development environment that Tristan will show you a little bit later is really succinct and is complete because it allows you to take a lot of your robot operating system extensions for the cloud, simulate them, and then build out something called fleet management. Now, keeping in mind that while this has been around for an extended period of time, ROS 1.0 and 2.0, there are lots of customers that are using the platform today. You'll see here on the screen there are several. Many of you are familiar with the Jet Propulsion Laboratory and others, but robotics has been around for some time, so it's really nice. Even in the education realm, we see a lot of academia and education alike. Several universities are already using the program, so this is really cool that we can take advantage of it for the public and ourselves as well as builders. Now, what about the development environment? This is very important, and we're going to see this demonstrated later. But as we start to think about development, we want to focus on how the application should get from ground zero and then to a deployment fashion. We create the RoboMaker development environment with a single click of a button, which is really nice. We also want to make sure that at that point in time, I can compile, I can download, and I can make sure that I configure all the relevant elements for the raw system to come to life. And then when I add the intelligence with regard to the simulation, I've got all of those extensions that are part of the environment that make up the cloud system of RoboMaker. So now I've developed this platform, I've built this compiler, I've got my IDE environment for my distribution, I've got my simulated robot, I have my extensions that have been now placed into the environment, and then now I can put my bundle inside of our S3 service, which is our storage platform. So I can now simulate this environment, which is where all the fun now starts to begin. So as we focus now on specific cloud extensions, you'll see that many of these extensions in AWS are built primarily for your benefit. We've got a very broad selection of services around machine learning to make sure that you can monitor and maintain the analytics environment. You can look at the logs to get familiar with all the packages. And then what's of utmost importance to AWS for our customers to make sure that you have secure connections so that your robots and our cloud environment will be securely protected. And then finally, you have the applications that get added on as well. Now, some of those extensions, which are very important, we've got speech recognition all the way down to our logging in monitoring services. So Amazon Lex allows you to incorporate speech. We can generate speech with our Poly service. We can do lots of live streaming from the robotics themselves in the simulated environment with our Amazon Kinesis video streams. And then now we can look at some type of recognition, facial analysis, including the robotics themselves, so that you know how the images and the videos are correlated together. And at the end of all of this, you'll finally bring it together with Amazon CloudWatch so that you know how the robots are functioning real time, their live movements, and then you're getting the feeds from how they're functioning mechanically speaking. So with our CloudWatch extension, as mentioned, you want to make sure that the robots themselves can give you the monitoring speed. You've got collectors to get the metrics. You'll also see the security of the platform. And then we're going to report that out as an output to ensure that you have a very holistic and seamless environment with each individual node that you are adding to RoboMaker. Now, what's also really cool is that these sample robotic applications that are out there today, we have several of them, and the typical one that we are all familiar with, Hello World, allows us to really get started into how we use the platform and then how we can monitor and navigate seamlessly through the environment. We can issue those voice commands, and then where you really see the rubber meeting the road is when the self-driving reinforcement learning kicks in, which is the fun part of this particular project. So where do we go from here? Well, thinking about the simulations themselves, we know that several things have to come together. We build the hello worlds, we have these pre-built 3D models that are out there for your benefit. But if you want to get really creative, and we challenge you, Tristan and I, myself alike, we want to make sure that you possibly build your own platform so that now you can see how this can be effectively used in a real world environment. From zero touch infrastructure all the way down to the simulations, having parallel processing, and then being able to auto scale this out. If you think about this holistic simulation here, this architecture really is designed just to do that. From the client itself to the terminal where you're processing and building, which Tristan will demonstrate a little bit later. You have this inside of your virtual private cloud environment, which is extremely secure. You've simulated this, you've added all the extensions so that you know how the platform is doing. And then to the far right, you see all of this come together. I have rules that I create in CloudWatch that allow me to alarm, to notify me, to simulate, to report the logs, and then to build out really something special for you and your customer or your own personal creativity. Now, what about when we want to take this from a single deployment to something that's now massively produced? Well, that's where Fleet management comes in. So, what exactly is fleet management? Well, it allows you to take and look at some of our services like AWS Greengrass, where we want you to be able to function and take code and push it to the edge of your environment and allow you to run autonomously or also off book if needed in a robotic type way. Now, that means that with this built in robot registry, I can secure the environment, I have fault tolerance, and more importantly, once again, we are managing all of this through the console. So on this slide here, you'll see that the packages themselves, how we launch the files, how we add several different environment variables. All of this means that if I have one robot app and I want to deploy 100 robot apps, I now have a framework, a template to follow. Whether I'm focused on x86 or I want to do something with ARM, all of these are different choices for you. But that green grass core that we talked about a moment ago, now I can take my code as service and then use it on the edge and then push this into my environment. And then now I have this thing that's come to life with my robot, all because I've developed this code that's really succinct and seamless in your environment. Now, you'll also note that with this fleet management, I can decide that I want to concurrently deploy 10, 15, 20, or I only want to deploy 20% of my apps. But what you'll see through our CloudWatch and our monitoring and logging service, that I can also demonstrate and follow the failure ratio. So I can have my threshold to be up or down, and then I can be notified on it so that when I've deployed a job, how many of those robots are actually alive and well. So let's put this all together so that we can get to something practical by way of a demo. You'll see that with regard to this platform, we've got speech, we have recognition for the images, we have live streams, we have the ability to capture logs, we can build out our own framework. You can build your own application, you can debug the environment. I can add machine learning as well. Several different AWS tools are at your disposal. And all this is based on ROS and ROS 2.0 so that you can have a successful deployment and experience in this platform. So, what does this mean from here? Well, that we should turn it over to Tristan. That's what it means, so that we can go through a demo at this time.
All right. Excuse me. All right. Thank you very much, Wayne. So we put in a little bit of a shameless plug in here where we have published a step-by-step tutorial on how to actually train a robot using reinforcement learning with AWS Robo Maker. So I highly encourage you guys to take a look at it. It is what the sample application that we're going to go through today. We also had followed up with a blog that basically goes into details on how this sample application works. So I put up the links here, which we'll share with you later. So basically, what is reinforcement learning? So just at a very high level on reinforcement learning and how it works. And with reinforcement learning, there's really two major components. The algorithm or the agent on the right-hand side that you see on the slide that basically learns not through a label set of data. That's what's really powerful about the reinforcement learning. So it uses the algorithm or the agent that it calls. A basically what I experiment inside of a simulating environment on the left, and the environment could be anything. It could be a supply chain simulation, a manufacturing process, and in this case, a robot designed to track a stationary object, which I'll show you a little bit later. And the simulation includes all the environment variables such as the robot directions, the speed, and you'll see that in the code also it takes the camera images as the what is called states to feed into the agent to decide what the next action, the best course of action should be. And the actions of the system can go left, right, and so on and so forth. So initially, the agent has no idea which actions are the best, right? And its guesses are usually wrong, but the agent guesses the best actions to take. Then the environment calculates the new states and reward based on the action taken. The reward lets the agent know how good its last action was. So the agent and the environment interact, deciding on the the new actions and calculating its new states. The agent accumulates positive rewards for its good actions and negative rewards for its bad actions. And that's how the agent learns to actually achieving that goal. And when the one round of the training ends, the robot has a total rewards that tells it how well it did overall. And over time, through many, many rounds of iteration of training, the agent or the algorithm basically slowly learns which actions are better or favor those actions while making those decisions. So without further ado, let's go ahead and jump on the console and I'll show you how everything works together. So when you go into the AWS RoboMaker console, first thing you want to do is to open up a development environment. You can click on the Create Environment button, and in here you can say Webinar Demo, and then I'm going to pick a M4 large. Then in this VPC, just pick one of the default VPC that actually has internet access, and click Create. So what this create does is that it creates a AWS RoboMaker themed Cloud9 IDE behind the scenes for you. So this takes a few minutes. So without waiting on this, I already have a Cloud9 environment that's already created. It is called RoboMaker Demo. So in here, I already downloaded the code. Now, what you would want to do is that once the environment comes up, what you want to do is you go to resources and download samples, and then go to number 5, object following using reinforcement learning. So what this actually does is actually it will download the source code onto this Cloud9 environment, and it will look like something like this. So once you have this in the place, first thing you wanted to do is that you wanted to make sure that you change the RoboMaker settings file, which that comes with the project. Now in here, what you want to do is you want to make sure that you wanted to fill out some of the required parameters, such as the S3 bucket. As you can see here, I already filled it out by my and some of the regions and everything else. It's going to ask you to put that in. So you want to make sure that you put those information in there. Now again, if you go back to the tutorial, it will actually show you the detailed instructions on how to actually get those done. So once you have all of these things the settings put in, what you want to do next is that you go to the I want to show you how it actually starts. If you go to the local training package file, so that's what this the ROS will do for you. Let's see here. I can find it. Oh, that's where it starts. So if we go back to the RoboMaker setting file again, as you can see here, it'll say local training.launch. This is the launch file that's actually going to launch telling the simulation to actually launch. So if you go and click on this file, and you see that this is the launch configuration for this simulation application, and it's going to run the shell script file. So this shell script file is right here. So if you look at this, it basically is going to launch a Python file called single machine training worker. So this single machine training worker file basically is the application entry point. And in this file, the environment variables such as the Markov preset file right here that you have put in, that's actually being passed in here so that it will know where the S3 bucket is at, where the application is at, and it creates a new TensorFlow model if it doesn't have one. You can see here, it's going to try to load the TensorFlow model from S3 if it doesn't exist. And after that, it actually creates a graph manager, which what it will do is all of these parameters creates this graph manager object and is responsible for training the model. Finally, training starts when the improved method of the graph manager object is actually called. So if you look at the object tracker.py file, This file basically contains the hyperparameters for configuring the reinforcement learning environment. The application uses a learning strategy known as the CLIP PPO, which is a proximal policy optimization. So PPO is an algorithm recommended by OpenAI as a really good starting point for reinforcement learning. It also has few parameters to tune other than reinforcement learning algorithms, but it still provides a very good overall performance. So let's go ahead and take a look at the object tracker environment file, which is what the that has all of the states, reward, and as well as action, right? So this file right here. What this will do is that it has in this application, the robot will use its camera to basically move around. And remember that the goal is for this waffle pie or this turtlebot to be able to reach to the stationary turtlebot burger. And I'll show you what that looks like eventually. And for every action that it takes an image of from its camera as the current state for every action that it takes. And then if the current distance between the turtlebot is less than it was from the last state, basically the turtlebot is moving closer to the stationary burger, the object that it's trying to track, then it gets a reward. If it does not, as you can see here, it's doing the calculations, taking the image from the camera here, and it's going to calculate how far it is from the actual stationary turtlebot. And here is the reward function here. And if it's actually moving closer than the last known distance, it's actually going to get a reward. If not, it will not give the reward. So obviously, the closer the turtlebot, the waffle pie that in this case it gets to the goal, the greater the reward that it's going to get. And if the distance is longer than 5 meters, the waffle pie is just too far from the stationary turtlebot burger, and the agent just ends the episode and starts a new one. And that's how the training just continues. And eventually, the waffle pie will learn on its own on how to actually track and getting the rewards, maximizing that reward, and be able to get to the turtlebot, the um, the burger eventually. So now that I've shown you the code, what you will want to do next is that what you would do is you click on Run, and you want to click on Workflow and click on the Object Tracker, Build and Bundle All. Now, what this will do is that it will actually build the application and bundle it all together into a zip format. And once you have done, this takes about 10 minutes. So I'm now going to show you how that's what it will look like. What it will. We're not going to do this in this session. But once you click on that, it takes about 10 minutes to build this. Once it's done, what you want to do next is that you go to Run, and then Launch Simulation, and then Object Tracker Train Model. So this will actually take about 8 hours, as obviously it takes time for the agents to be able to learn itself on how to actually track that object eventually. So once the training job is done, then you can click on the evaluate model, and that's what we're going to do. I already trained a model here for you guys, so we're just going to evaluate the model that based on the model that we already trained. So when you click on this, what it's going to do is it's going to upload the bundled file and the model onto the, as you can see here, it will upload onto the S3 bucket that you specified, and it's going to start a simulation environment. And it says it's created. So now you can see here that the simulation is actually saying it's preparing. This takes about 1 or 2 minutes for it to start. Once it says running, then we can actually go ahead and take a look at what's actually in it. You can also go back to the RoboMaker console and then go to simulation jobs and look at the, as you can see here, that's the same job that's actually in the preparation mode. but we made it a lot easier for you guys that you don't actually have to leave the Cloud9 IDE and just be able to access the same thing that you will be able to access from the RoboMaker console, so that you don't have to leave a different tab or a different place. So we'll give it a few more minutes. Almost there. Okay, so now the simulation is running. You can actually access this everything from the Cloud9 IDE environment. So for example, if you go into applications and Gazebo, you can actually look at the robot, the environment right here. So in this example, as I mentioned before, this waffle pie, which is the turtle bot that's actually moving, it's tracking this burger turtle bot right here. It's trying to move to this turtle bot burger by itself autonomously through reinforcement learning based on the training that I have done for 8 hours. As you can see that it's tracking towards to the this stationary burger, and it just replays the same episode. So if I move this guy around, for example, it should be able to see here. It should be able to see the change and make the direction change and go track towards the new direction. So this is all autonomously decided based on the images that is feed into the waffle pie, the moving robot here. So this is completely done by the reinforcement learning agent, the model that they had trained. It does not have any kind of human interactions here to tell this waffle pie to make that direction change and go to that stationary burger. So basically, this is how the reinforcement learning works. I highly encourage you guys, Wayne and I encourage you guys to take a look at it and play around with it. Um, like I said before, if you go back to the code, um, take a look at the reward function and see if you guys can improve it. It uses the images as the state that goes into take into consideration, and it makes the calculation to say if it's actually closer to the burger or not. If it is, then it gets a positive reward. Maybe you can you can update the reward function and make it more interesting so that uh, give it a negative reward. If it doesn't, we didn't put in a negative reward in here, but you can put in a negative reward if it's actually moving away from the object. Just make it more accurate, make it perform a little bit better than what we have proposed, what we have put in here. And that's really pretty much it for this application. But let me take you back to the RoboMaker console. So in here, I mentioned about the development environment where we actually created a development environment, download the source code, compile the code, bundle the code, and then we train it in a simulation environment. Then we evaluate it in a simulation environment. So now, if you're happy with the model that it had trained through evaluation, as what we had done earlier, what you want to do next is that you wanted to deploy onto an actual robot device. This is what Wayne had mentioned about the fleet management. So you go into the robot, what you want to do first is you want to create a robot. Now, I don't have a robot with me right now, but basically, if it's a waffle pie, like what we shown in a simulation environment, what you want to do is that, obviously that is the ARM architecture, and then you wanted to create a robot. like so. So as Wayne mentioned about, it uses Greengrass, AWS Greengrass to actually deploy the model and the application onto the actual robot, so that you can create a new one here. You can create an existing role. I'm not going to go through this because, as I mentioned, I don't actually have a robot with me today. But this is the steps that you actually set up a robot, set up the Greengrass, actually configure it so that it will be able to communicate with the AWS Robo Maker. And once you have set it up correctly, the status will say from failed to actually active or online. So that way you know that your robot is actually communicating with the AWS Robo Maker service. So once you're done with that, you want to create a fleet. And then the fleet will basically will manage it's really just a way to manage the robots, as Wayne mentioned earlier. So in here, you can say webinar fleet. Just going to show you guys what it looks like. You create it. Then once you're done in the fleet, you can register your robot. So in here, as I don't have an active robot, so you won't be able to see that here, but you can actually create a robot once you have that robot online. So once you have your fleet, excuse me, once you have your fleet, you then do your deployment. So you create a deployment, the actual deployments, and choose the fleet that you wanted to deploy to, and choose a robot application. And one of the things that I forgot to actually mention it to you guys was that if we go back to the Cloud9 IDE, you see that there are two workspaces. Now, if you guys work with ROS before, you guys know what I'm talking about. There are really two workspace. One is the simulation workspace and the robot workspace. Now, with the simulation workspace is where we did the training, the evaluation, this reward function here. All of these things are all defined in this simulation environment. Now, if you think carefully that really you build a model in a simulation environment, and then you don't really do the training anymore because the training has already been done in the simulation environment. Then you deploy the model in the robot workstation. This is the code that actually gets deployed onto the robot itself. So you don't really actually need this training, all of these training code anymore, because at that time your model is already been built and you're really just deploying that TensorFlow model. And just to show you guys what it looks like, if you look into the actual code for the robot workspace, you see that there's a download model. What it does is actually it goes onto the S3 bucket that you specify in the RoboMaker settings file. It's going to download that model, and then it's going to deploy that model through the Greengrass onto the robot. And then it's going to execute this inference worker. So if you look at this inference worker, what it does is actually importing the TensorFlow. As I mentioned, the model is actually in TensorFlow in a frozen graph. What it will do is that it's going to actually load that graph onto it and then make predictions, or based on the images that it sees, and it's going to track that, and it's going to start taking actions, whether they're going to turn left, turn right, move forward, all of those things as you saw in the simulation environment. So it's really in here in this robot workspace, there is no more training because the training has already been done, has been validated by you, and it really just did using that model that it had trained from the simulation environment and start actually running with it. I hope that makes sense. So let's go back to the RoboMaker real quick. So you pick the robot application. That's what that robot workspace will do. So you pick that the object tracker application, and then the package name and all of those pre-launch files and those type of things. Make sure that it actually will launch into the actual device, and then you can create the concurrent the concurrent deployment percentages. Remember what Wayne had mentioned about earlier about the rollbacks. If the failure threshold percentage, if they're 25% reaching, if you say for example if you have 4 robots and one of them failed, that kind of reaches the 25% failure threshold, and then they'll actually roll back. So you create a deployment. Once you hit the create, it will actually try to deploy that robot application onto the robot itself. So after that is this is basically what the RoboMaker environment looks like. You can use the RoboMaker service again, use it for the development environment. We have a built-in development environment using Cloud9 for you to use, and the simulation jobs. And if you guys have used gazebos, RViz, all of those things are all part of the ROS operating system, the framework, RQT. You will be able to actually use that here as well. So for example, if I wanted to go into RQT, you can just click on this here, or you can click on it from the RoboMaker IDE, the Cloud9 IDE. So in here, if you guys are work with ROS before, you can do the same thing here. So for example, if I go into plugins, go to topics, and maybe take a look at topic monitor and take a look at images and see what is the messages that's actually being published to that. As you can see here, that they will see the messages that's actually being published to that topic, right? All right. What else do I want to show you guys? I think that's pretty much it. Going back to the slides. So just a few things. As far as pricing goes, the service itself is for the most part is free. Now, what that means is that the Cloud9 is the resources that you are using that you're going to pay for. So, for example, the development environment, the Cloud9 development environment, you're actually paying for the EC2 instance that's actually running behind the scenes. Same thing with cloud extensions. The extensions itself is actually free, but if you're using the recognition service or Kinesis service or the CloudWatch and those type of things, you actually pay for the services itself. Now, so for the most part, such as the Cloud9, the cloud extension, they're all free, but the simulation is a little bit different. The simulation is the only place that you actually have to pay when you run a simulation in AWS RoboMaker, and that's the pricing that is it's breaking down into simulation units. Basically, it's about one virtual CPU and 2 gig of memory is about 40 cents per hour in North Virginia. The fleet management again, this is free as well. But for the Greengrass service that you use, you're actually being charged for that. So that's really the pricing components for the different environments, also the components that actually we have for AWS RoboMaker service. Again, going to additional resources, the step-by-step tutorial that we had published for the sample application I kind of walked you through today briefly. Highly encourage you guys to actually do some hands-on and follow that. It's step-by-step, very easy to do. If you guys have a waffle Pi, I encourage you to kind of deploy that onto a waffle Pi and see how that performs, and modify the environments a little bit as well, and see if you can make it to track something else and do something else with reinforcement learning. And also look into the reinforcement learning with AWS RoboMaker blog and kind of dive deep a little bit with what we just talked about today. How to modify the reward functions and the states and all of those things. So, and also other sample applications, highly encourage you guys to take a look at, get your feet wet, and you can always learn more from our AWS RoboMaker. And with that said, thank you guys very much for your time. And Wayne and I highly encourage you guys to take a look at it and let us know how you feel.
Yep. Thank you very much, and we hope you all have a nice day. Take care.